Good morning, students. Now, in this class we are going to continue with derivatives of inverse trigonometric functions. So, in the last class we have seen some of the derivatives, standard derivatives of inverse trigonometric functions. Now, we shall solve some examples based on these. So, the first one is find the derivative of y is equals to, the function is given by y is equals to tan inverse of 3x minus x cube divided by 1 minus 3x square. The value of x lies between minus 1 by root 3 less than x less than 1 by root 3. So, this function is defined in the values of x lying between minus 1 by root 3 and plus 1 by root 3. If we want to find the derivatives of inverse trigonometric functions, we need to apply first the substitution method here. So here I will substitute in this. Let x be equal to tan theta. Let x be equal to tan theta. Here x is also a variable, theta is also a variable. Now I am going to differentiate on both these sides. Differentiate on both these sides with respect to x. So dx by dx will be equal to d by dx of tan theta. Or you can also go for another method here. The method is, if x is equals to tan theta, then my theta will be equal to tan inverse of x. Theta will be equal to tan inverse of x. So I will take this function y is equals to tan inverse of 3 times tan theta minus tan cube theta divided by 1 minus 3 into tan square theta. Now, this will be tan inverse of tan of 3 theta. So, tan inverse of tan is the theta only. So, this is 3 theta. So, y is equals to 3 into tan inverse of x. So, by substituting, what we have come to the conclusion, we have reduced this to y is equals to 3 into tan inverse of x. Now here I will be differentiating. So differentiating with respect to x, we get dy by dx is equals to d by dx of 3 into tan inverse of x. So dy by dx will be equal to 3 divided by 1 plus x square, because the derivative of tan inverse of x is 1 divided by 1 plus x square. Remember, here we have applied the formula. Here we have substituted x is equals to tan theta. So once we substitute x is equals to tan theta, theta in terms of inverse function can be written as theta is equals to tan inverse of x. Now wherever x is there I will be substituting tan theta. Wherever x is there I will be substituting tan theta. So it is 3 times tan theta minus tan cube theta divided by 1 minus 3 into tan square theta. 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta is tan of 3 theta. In inverse trigonometric functions, you have studied that tan inverse of tan theta is theta, but here theta is 3 theta. But what is theta here again? Theta is going to be tan inverse of x. So this function we have reduced. This function we have reduced to y is equals to 3 into tan inverse of x. Now here I will be differentiating it with respect to x. So dy by dx will be equal to d by dx of 3 times tan inverse of x. So dy by dx is 3 divided by 1 plus x square. Similarly, the next problem that we are going to see, y is equals to sine inverse of 1 minus x square divided by 1 plus x square. Y is equals to sine inverse of 1 minus x square divided by 1 plus x square. So here I will be substituting x is equals to tan theta again. Substitute x is equals to tan theta. So theta will be equal to tan inverse of x. So here theta will be equal to tan inverse of x. So y is equals to sine inverse of 1 minus tan square theta divided by 1 plus tan square theta. The result is y is equals to sine inverse of 2 theta. 1 minus tan square theta divided by 1 plus tan square theta is sine of 2 theta. So sine inverse of sine theta is theta. So this is 2 times theta. So y is equals to 2 into, but what is theta? Theta will be tan inverse of x. So 2 into tan inverse of x. Again here what we will be doing? Differentiating with respect to x. I will be differentiating it with respect to x. So dy by dx will be equal to d by dx of 2 into tan inverse of x. So dy by dx will be equal to 2 divided by 1 plus x. Now this is what? Just look here. Here I have taken for x, I have taken x is equals to tan theta. So theta will be equal to, this is going to imply theta will be equal to tan inverse of x. So y is equals to sine inverse of 1 minus tan square theta divided by 1 plus tan square theta. So y is equals to sine inverse of sine of 2 theta. So y is equals to 2 theta. So y is equals to, what is theta here again? Tan inverse of x. So differentiating with respect to x, what do we get? dy by dx is equals to d by dx of 2 into tan inverse of x. So dy by dx is going to imply it is 2 divided by 1 plus x square here. Now the next one I am going to slightly change. Instead of sine inverse, I am going to take here cos inverse. Y is equals to cos inverse of 1 minus x square divided by 1 plus x square. Here again the same substitution. The substitution is let x be, or you can write here substitute. So substitute x is equals to again tan theta. This is going to imply theta will be equal to tan inverse of x. Theta will be equal to tan inverse of x. So y is equals to cos inverse of 1 minus tan square theta divided by 1 plus tan square theta. So y is equals to cos inverse of sine of 2 theta. Here, because the formula says 1 minus tan square theta divided by 1 plus tan square theta is sine of 2 theta. Now this sine you will be converting in terms of cos. So y is equals to cos inverse of cos of pi by 2 minus 2 theta. So this will be y is equals to pi by 2. Y will be equal to pi by 2 minus 2 theta. So y is equals to pi by 2 minus 2 into tan inverse of x. Because sine of pi by 2 minus theta is cos theta. Now here differentiate with respect to x. What you are going to do? You are going to differentiate it with respect to x. You get dy by dx will be equal to d by dx of pi by 2 minus 2 into tan inverse of x. So dy by dx will be equal to derivative of pi by 2 is 0. So here minus 2 divided by derivative of tan inverse of x is 1 divided by 1 plus x square. So this is how you are going to solve this problem. Just note the difference between the previous problem and this problem. There In the previous problem you had got it as a sine inverse of sine of 2 theta, that was 2 theta. But here you are getting it as cos inverse of sine of 2 theta. Cos inverse of sine of 2 theta. So here first you have to convert sine in terms of cos. Once you convert sine in terms of cos, you are going to apply the formula cos of pi by 2 minus 2 theta. Now cos inverse of cos. Cos inverse of cos is the angle theta. But here theta is pi by 2 minus 2 theta. So here you are going to differentiate it now. Here you are going to differentiate. So differentiating with respect to x, what do you get? Dy by dx will be equal to d by dx of pi by 2 minus 2 into tan inverse of x. So dy by dx will be equal to minus 2 divided by 1 plus x square. Minus 2 divided by 1 plus x square. Now, the next problem, y is equals to, I am going to take the next problem. The next problem is y is equals to sine inverse of 2x into root of 1 minus x square for the values minus 1 by root 2 less than x less than 1 by root 2. Here, instead of the substitution tan, I will be substituting x is equals to either sin theta or either cos theta. Or better, it is sine inverse. So here I will be substituting x is equals to sin theta. So substitute x is equals to sin theta. So this is going to imply theta will be equal to sin inverse of x. So here y is equals to sin inverse of 2 sin theta into root of 1 minus sin square theta. So y is equals to sin inverse of 2 sin theta into cos theta, because root of 1 minus sin square theta is cos theta. Now there is a formula that sin of 2 theta is 2 sin theta into cos theta. So y is equals to sin inverse of sin of 2 theta. So y is equals to 2 theta, because sin inverse of sin is 2 theta. So y is equals to 2 into sin inverse of x. Now we are differentiated with respect to x. You get it as dy by dx will be equal to d by dx of 2 into sin inverse of x. So dy by dx will be equal to 2 divided by root of 1 minus x square. So these are the problems, right? So in the next class I will be proceeding with some more problems, and in the next class I will be explaining you what are exponential and what are logarithmic functions.